everyone, welcome to Chemistry Stars. We have already done with the first, second, third category of classification of polymers. Now we are going to study the fourth type of classification of polymers, that is on the basis of molecular forces. So on the basis of this molecular forces present between the polymer chains, we can classify polymers into four different categories. The first category is known as elastomers, second category fibers, third one thermoplastic, and fourth one thermosetting plastic. So first of all, let me tell what are elastomers and fibers. After that, I'll tell you about thermoplastic and thermosetting plastics. Okay, remember these four names. Okay, now let us look what are elastomers. Elastomers are, from the name itself, you can say that they are rubber-like solids. Okay, we can say that they are rubber-like solids. Okay, because they have elastic properties. Fine. Okay. Now, fibers means they are thread-forming solids. Elastomers means they are rubber-like elastic, rubber-like solids which have elastic properties. But fibers means small thread-like structures, right? So here they are fibers means thread-forming solids, and they have high tensile strength. That is the property of fibers. High tensile strength means they are strong fiber. Okay, they are strong fiber-like thread-like structure, so we cannot break them very easily. Okay, they are very tough, so we can say that fibers have high tensile strength. Now the third point is elastomers. When they have elastic properties, there will be from that itself you can say that they have weak intermolecular forces. Okay, comparatively fibers have strong intermolecular forces, and that strong intermolecular forces means that bond can be hydrogen bonding, that is between the polymer chains of these fibers. We can see hydrogen bonding, and hydrogen bonding is a strong intermolecular force of attraction. Okay, now as they are rubber-like and they have weak weak intermolecular forces, they can be stretched easily. Okay, elastomers, we can stretch elastomers very easily, and here fibers are very crystalline in nature. Crystalline, we cannot stretch them. Okay, they are very crystalline solids having high tensile strength. Okay. Now let us look into the examples of these elastomers and fibers. This is very important. Examples are very important. Fine. Okay. So examples, if I talk about the example of elastomers, see, elastomers means they are, from that name itself we can say that rubber-like solids, right? So natural, you can give example as natural rubber, neoprene, Buna S, Buna N. Buna S and Buna N are rubber, right? They are synthetic rubbers. So these are the examples of elastomers. And in case of fibers, nylon 66, terylene, these all are fibers. Nylon 66 is a polyamide. We have seen this in the previous video, nylon 66. And terylene is a polyester. I will tell about terylene in the upcoming videos. Okay, so remember these classification. This is very easy to remember. So remember the points, and most importantly you have to by heart the examples. Okay. Now let us look into the remaining two categories of polymers, that is thermoplastic polymers and thermosetting polymers. See, this classification or this differentiation between thermoplastic and thermosetting polymers are very important because there is a great chance to ask this type of question related to this classification in various exams like CBSE board, state board, or also I can say this portion is there in the syllabus of various universities. So you have to remember this every points related to each of these categories, and examples are also very important. Okay, now let us look into the thermoplastic polymers. So listen properly and study this classification thoroughly. Fine. Okay, if I talk about the thermoplastic polymers, they are linear or see slightly branched. Okay, slightly branched polymers. Thermoplastics are linear. Most thermoplastic polymers are linear, or sometimes they can be also seen as slightly branched ones. Polymers. Now, thermosetting polymers, they are highly branched, or you can say heavily branched, okay, or extensive cross-linking is found in thermosetting plastics. Extensive, not extensive cross-linking. This I'm writing cross-linking are present. Now, thermoplastics. When you heat thermoplastics, on heating, thermoplastic becomes soft. On cooling, they become hard. So when we do continuously this heating and cooling process, or we can say on repeated heating and cooling, they can be reused. Okay, even though we repeatedly do these two things, we can reuse it. Okay, so they are reusable. They are reusable. In case of this thermosetting polymers, they on heating itself, they become infusible solid masses. Infusible solid mass. Okay. Or when we heat thermosetting plastics, they become infusible like thing. Okay. So they cannot be reused. Cannot be reused. So they are non-reusable. Fine. Once you heat a thermosetting plastic, it will set. Okay, that is from the name itself you can get that, right? Once you heat the thermosetting plastic, it cannot be reused again because it becomes a infusible solid mass. Now, the intermolecular, remember a point that intermolecular forces of thermoplastic polymers is in between. Intermolecular forces is in between. Okay, is in between fibers and elastomers and fibers. We have already learned about the elastomers and fibers, right? So the intermolecular forces present in thermoplastic polymers are in between elastomers and fibers. Okay, not as elastic as elastomers or not as tough as fibers. Fine. That is thermoplastic. Now, thermosetting plastic means, see, when you heat on heating, see the extensive cross-linking. There are cross-links between the polymer chains in thermosetting plastic. So, when we heat thermosetting plastic, the cross-linking becomes more extensive. Fine. The cross-links becomes extensive. Remember this point also. Now, if I talk about the examples of thermoplastics, see, examples are, thermo means something related to heat, right? Plastic polymers means they are polymer. So, here we have almost all plastic, that is like PVC. PVC is a plastic, right? Polyethylene. I have already taught you the structures of PVC and polyethylene in the previous videos. Polystyrene, these all are thermoplastic polymers. Now, thermosetting polymers means, here what the name suggests, thermosettings means if you give the temperature, they set. Okay, that is thermosetting polymers. Now, the examples of thermosetting polymers are, see, bakelite. Remember this, okay, this is very important. Bakelite, urea formaldehyde resin. Urea formaldehyde resin. Okay, these two are the examples of thermosetting polymers. Now the next topic which we are dealing is about, it is a different topic. This topic is over. Fine, that is about addition polymerization, condensation polymerization. So there is a mechanism related to addition polymerization. This is given in your textbook. So you have to learn that. I'll upload it in the next upcoming video. And I have created a playlist related to this polymer chapter, so you can go to that playlist and watch all the videos related to polymer chapter from this channel. And till then, bye bye. Okay.